Heidi-ho, Renaissanceteers! This is the solution to Renaissance puzzle number 109, Pyramid Power. But before you look at the solution, you still have a chance to solve the puzzle and earn a Renaissance point. The puzzle is given here once again, so if you want to solve it, pause this video now and study the puzzle. Otherwise, in just a moment, the solution will be presented. Heidi-ho, Renaissanceteers, and welcome to the solution to the ball in the pyramids problem. Imagine flying over the cluster of 4 pyramids and looking down at them from above. These 4 circles mark the peaks of the pyramids. And here is the ball dropped into the center of the 4 pyramids. These 4 red lines are the pyramid edges that are in contact with the ball. The sides at the base of each pyramid have a length of 1. The Pythagorean theorem says that this diagonal length is the square root of the sum of the squares of the 2 adjacent sides, so its length is the square root of 2. Therefore, the distance from the center of each pyramid base to one of its corners is 1/2 the square root of 2. Now imagine standing on the ground at the corner of the 4 pyramids, looking along this diagonal line. If you removed the pyramid directly in front of you, this is the view that you would see. We just calculated that the distance from the center of a pyramid to a corner is 1/2 the square root of 2. In this view, we will call that length triangle side A. Triangle side B is the height of the pyramid, and we were told that the height is 2. C is the hypotenuse of the right triangle ABC. Now let's draw a radius line from the center of the ball to the point where it touches the red line of the pyramid edge. Let's call this radius X. And let's call the other 2 sides of the newly formed triangle Y and Z. We know that the red line C is perpendicular to the radius. Furthermore, we know that these 2 vertical lines are parallel. Therefore, these 2 angles are the same. This means that triangles ABC and XYZ are similar, which means that their side lengths are proportional. Therefore, A is to X, as B is to Y, as C is to Z. Again, we use the Pythagorean theorem to find C. C is equal to the square root of 2 squared plus the square root of 2 over 2 squared, which is the square root of 4 plus 1/2, which is the square root of 9 divided by 2. Now let's use our similar triangle relationships. A over X is equal to C over Z, and plugging in the known values we get the square root of 2 over 2 divided by 1/2 is equal to the square root of 9 over 2 divided by Z. Rearranging terms, we get Z is equal to the square root of 9 divided by 2 over the square root of 2, which is equal to 3/2. So the top of the ball is at the height Z plus the radius of the ball, which is 3/2 plus 1/2, which equals 2. So the answer is that the top of the ball is exactly even with the peaks of the pyramids. I bet that was a surprise. Happy Renaissancing!